Hello everyone. I would like to introduce our work TransRegex. The authors are from University of Chinese Academy of Sciences, Institute of Software Chinese Academy of Sciences, Shenzhen University, and the Hong Kong University of Science and Technology. Next, I will introduce our work in 4 parts. First, introduction. Regular expressions, for short, regexes, have been widely used in different fields of computer science. Unfortunately, regexes can be difficult to understand and compose even for experienced programmers. To alleviate this problem, several techniques generate regexes from natural language descriptions, while others from examples. However, the existing NLP technology is affected by the training set and the ambiguity of natural language. The example-based synthesis approaches rely on high-quality examples provided by users. Obviously, the quality of the examples will lead to overfitting and underfitting problems. So why don't we combine language descriptions and examples to generate regexes? In this paper, we propose a multi-modal synthesis framework, TransRegex, which can synthesize regexes from both natural language descriptions and examples. We present a 2-phase model S2RE for natural language to regex, and a novel algorithm SynCore for regex repair. Next, overview and algorithms. This is the overview of TransRegex. First, the user provides examples in natural language descriptions. Through an NLP-based regex synthesizer, realize natural language description to a regex. Then TransRegex judges whether the regex is consistent with the example. If they are consistent, the regex is returned. Otherwise, the regex is repaired by a regex repairer. Let us consider a task: generate regex in the shadow. The natural language description, the positive examples, and the negative examples are shown in Figure 2. Intrinsically, the description is ambiguous. It is unclear what part of the string should appear at least 7 times. First, TransRegex utilizes S2RE to translate the natural language description into a regex. S2RE consists of an encoder and a decoder. For this task, the encoder generates latent vectors from the given description, and the decoder synthesizes the corresponding regex as the middle expression in the shadow. However, it is clear that this regex is invalid. So we reuse the structure of S2RE to build the model invalid to valid. It converts the middle expression into a valid regex. However, due to the ambiguity of natural language, the generated regex does not satisfy the example set. It is easy to verify that the valid regex is inconsistent with provided examples. Therefore, we need the second step of TransRegex, according to the regex R0 and a set of examples. Utilize a regex repair to obtain a regex R that satisfies the given example. First, we define an index f to describe the degree of the regex consistent with examples. Especially, the regex with f value of 1 will accept all positive examples and rejects all negative examples. We observe that the incorrect regex is generated by S2RE may be very similar to the target regexes. Therefore, SynCore first converts incorrect regex to the abstract regex, so that the integrity of small subregexes can be retained as much as possible. Then SynCore get the neighbors of regex. Next, SynCore maps these abstract regexes into corresponding concrete regexes, and calculates the f value of each regex. Finally, return the regex with f value of 1. However, considering that SynCore is based on neighborhood search and may trap in local optimum, we continue use rfixer to repair if SynCore fails. Third, evaluation. We conducted experiments to evaluate the performance of TransRegex. We answer the following 4 questions. In the experiment, we evaluate TransRegex on 3 public datasets as listed in Table 1. Note that the third dataset are more complex than the first 2 dataset. In terms of baselines, we select 6 NLP-based works as listed in the first part, and 4 NLP-and-example-based works as listed in the second part. We compare them with 3 variants of TransRegex. The first RQ, the effectiveness of S2RE. On the one hand, Table 2 shows, on these three datasets, the accuracy of S2RE is similar or slightly better than soft regex, and is always better than the other four NLP-based models. On the other hand, as for validity, we can see Table 3, less than half of the regexes generated by deep regex are valid, and soft regex achieves 90.6%. By contrast, S2RE achieves 100% validity ratio. Summary to RQ1. S2RE can achieve similar or better accuracy than the state-of-the-art NLP-based models. Meanwhile, S2RE can synthesize more valid regexes. The second RQ, the effectiveness of SynCore. Table 4 shows the number of successful repairs. We can find SynCore can repair 11.6%, 0.5%, and 14.2% more regexes than rFixer on the three datasets respectively. In addition, the repair success rate of SynCore plus rFixer is higher than that of SynCore or rFixer alone on the three datasets respectively. We demonstrate the advantages and disadvantages of rFixer and SynCore. As case 1 and 2, SynCore has high generalization performance compared with rFixer. Case 3 illustrate that SynCore can handle regexes with conjunction well but rFixer cannot. Similar to case 4, in some cases, SynCore will fall into a local optimum, and rFixer can solve them. Summary to RQ2. SynCore can more effectively repair regexes compared with rFixer. In addition, SynCore and rFixer are complementary and simultaneously useful for TransRegex. The third RQ, the effectiveness of TransRegex. We compared TransRegex with 6 NLP-based baselines and 4 multimodal baselines. We can see from Table 2 that on average, NLP-based works performed worse than multimodal works on all three datasets. On the first two datasets, the accuracy of NLP-based works range from 38.6% to 78.2%, compared with 68.9% to 86.4% achieved by existing multimodal works. On comparison, TransRegex reaching 90.3% to 98.6%. On the last dataset, the accuracy achieved by TransRegex almost doubled the accuracy achieved by deep regex plus X. Let us present a few example regexes that are synthesized incorrectly from natural language, but are correctly by TransRegex. As case 1 in Table 6, the description is ambiguous. It is unclear what part of the string would appear at least 3 times, resulting in that S2RE predicted a regex embedding other meanings. TransRegex utilizes examples to help disambiguate the description and fix the incorrect regex to the correct regex. Similar to case 2, 3, and 4 in Table 6, the errors that are caused by imprecision or unknown words in descriptions, or false prediction by NLP-based approaches, can be corrected by TransRegex through using the example-guided regex repairer. Summary to RQ3. TransRegex can achieve higher accuracy than NLP-based and multimodal works on all three datasets. The last RQ, the efficiency of TransRegex. We compare the average running time of synthesizing regex with the open-source baseline deep regex and S2RE in Table 7. In general, we can see that TransRegex takes longer time on the last dataset than on the first two, and NLP-based baselines take less than TransRegex on average. Considering together with the accuracy, TransRegex achieved the accuracy that doubles achieved by S2RE, taking only around 10 more seconds running time. Summary to RQ4. TransRegex can synthesize regex efficiently. Especially when considering together with accuracy, TransRegex can take an average 3 to 6 seconds to achieve around 20% more accuracy on simpler datasets, and takes 30% more accuracy at cost of 10 more seconds on the more complex dataset. Finally, to summarize our paper, we propose a novel framework TransRegex for synthesizing regexes from both natural language descriptions and examples. For NLP-based synthesis, we devise a two-phase algorithm S2RE. For regex repair, we present a novel algorithm SynCore. Thank you for listening.
So, hello, back to the live part of this session. Remember, we are in the session Programming General Issues, and I'm Gregorio Robles from the Universidad Rey Juan Carlos in Madrid, Spain. Our second paper is entitled TransRegex, Multi-modal Regular Expression Synthesis by Generate and Repair. And we have here the pleasure to have Yeting Li from the University of Chinese Academy of Sciences to answer your questions. So if you have any question, you have the chat on that side, just post them and I will ask it to Yeting. So in the meantime, while you write your questions, I have one to start a little bit and to warm up a little bit, Yeting. So, and actually I'm putting it here in the chat as well. So here you see it. So I've seen that when explaining the method, you say that you return the regular expression with f value of 1. And my question is there always a regular expression with the f value of 1?
Actually, it is more than one, but I will choose one.
Okay.
Yes, because the example is not enough. So maybe there are more than one f equal 1.
So
Yes.
when there is more than one, how do you choose the one, the final one?
Randomly. Yes, randomly.
Okay, so you just then take one randomly. Okay, that's fine enough. We have questions. So I see Laurie first. I don't know if she's trying to have their regular expression in the chat or if she's just testing. So I will skip her and go to Michael's question. So Michael asks, how does your work relate to the existing multimodal regal technique from PLDA 20? And did you consider comparing to it experimentally?
Well, I haven't. Yes, I haven't read this paper, but I will read it in later, and maybe in our future work we will do compare.
Okay, thanks. So that's fair enough. You have something then to do for the future, which is always
Yes,
good.
yes, thank you.
So, so is TransRegex available as a tool on GitHub, for instance, so that developers can make use of it?
I'm sorry.
Yeah, just imagine. I find your idea fantastic, and I've read your paper, and I like TransRegex. Is TransRegex available on GitHub, or have you released it so that others can use it?
In this stage, it is a portal implement, and it is not available yet. But I will release it after we complete it.
Okay, fantastic. That would be nice, because I think yeah, many people will have a look at it. So I see Michael says that the paper that he's referring to is cited in your paper. So
yes, I have cleared it. Actually, I am not Lee. He is in 6, so I am the 5 author. So I can explain it very clear. So
okay,
you're right. Yeah, and Lee is actually acting, sitting it, but for me, I haven't read it. I'm sorry.
okay, I see that's one of the things of specialization and teamwork. So there is another co-author who's the expert in that part, and no Yeting. Okay, that sounds as a feasible answer. So
Yes, as you can see, Thirdly, give a response to the previous. So he says this is not always one. Yes.
Okay, and what happens if it's not always one? I guess you take always the one with the maximum.
Oh, yes.
So if I understood it correctly, if you have got more than one with a F score of 1, then you take one randomly. If not, you just take the maximum value of the of the one with the maximum.
Yes, you're honestly right.
Okay, sounds good. Yeah, but I asked this because in the presentation, now you just referred to we take the one with the F score equals 1. Okay, that's now clear. So while other attendants put their questions in the chat, I would like you to ask. This is an easy question. So what would be the next steps?
We will generate anti-IDOS regular expression. IDOS is a tag, so we have to avoid it. That is in our future work.
Okay, thank you. Is this research part of your PhD or?
Oh yes, it is Lee's PhD.
So it's Lee's PhD. Okay.
Yes.
And then the PhD is on regular expressions, optimization of regular expressions.
Yes.
Okay.
Anything about regular expression?
Okay. Is there any paper that shows that regular expressions are more buggy than the rest of the code? I guess there is, but I'm not an expert in this field in regular expressions. I'm a regular user of regular expressions, but not a scientist in that way. But in how far are regular expressions more prone to be buggy than usual code? Has there any research been done on that?
I remember Davis proposed many research about regular expression. In recently, he proposed a paper in S&P. It's about IDOS.
Mm-hmm.
And I think regular expression is more comfortable.
Okay. For those who, as me, teach regular expressions in their lectures, with their university students, how would TransRegex change the way we present regular expressions? Do we have to change our way of presenting them? Could you elaborate a little bit on that? I mean, we just teach regular expressions in one way, but then how would TransRegex change that, if at all?
I'm sorry, I can't hear you.
Yeah, I mean, many of us teach regular expressions at university. If we have a tool such as TransRegex, how would you recommend us to introduce us this tool, if at all? I mean, how would you do that?
In teaching and for programming, it is helpful the user to write regex and to write regex. Yes, that's all.
Okay, well, we are running out of time. If somebody wants to talk to Yeting, there will be a discussion room displayed in a pop-up with a button that you can follow. And